week's RedMonk Conversation. My name is Kate Holterhoff, Senior Analyst at RedMonk, and with me today I have two giants in the messaging space and longtime friends of RedMonk, Andy Stanford-Clark, Distinguished Engineer and Innovation Leader in IBM Research, and Clemens Vasters, Principal Architect focused on messaging and real-time intelligence services at Microsoft. Clemens and Andy, thank you so much for joining me on the Monkcast.
Great to be here, Kate. Thank you.
Yeah, thank you for having me.
Yeah, this is going to be a really great conversation. I know it. So I'm hoping we can weave together a discussion of messaging that synthesizes, where we've been, where we're headed, because although messaging is a well-established and foundational computing technology, I have struggled in my own research to really pin down this story. So let's begin at what you would consider to be the beginning. Where did this need for messaging come from? What do you consider to be significant events in this timeline? How does it stretch to where we are today? So Andy, would you go first and trying to break apart this, I know, very challenging question.
So I think I'm going to start. So one thing that happened yesterday, I met my dad for the first time in a while, and we were reminiscing about the fact that it's MQTT's 25th birthday tomorrow.
Congratulations. Yes.
I thanked him for being so tolerant of me using dial-up modem on our home phone line when I was a teenager to contact all the bulletin boards that I used to dial up with my TRS-80 Model 3 computer, spending hours on making phone calls. And he said, yes, he thinks it had the only house in the UK where the phone bill was more than the heating bill, which was quite significant. But that really started my career in computing, my interest in getting computers to talk to each other. And another sort of interesting moment was a neighbour of ours, when I was a teenager, was asking me, he ran a holiday let company, and each site had its own computer. And he wanted to dial, he said, is there any way I can connect to all of them and bring all the accounts data centrally so that I can then do the centralized accounts? Because at the moment he had to phone people up and he had to post it to him or read it to him over the phone. And I said, oh yeah, you need a modem. And he came back to me with this mode M thing that you've been talking about. So it's like a special mode of computers. So he didn't know what a modem was, but to me that was the beginning of my interest in messaging. And this was before the internet, so it was when this was point-to-point dial-up connections to things like bulletin boards and CIX, a CompuLink Information Exchange we all used to dial into in London to download our messages and send what we now call emails to each other. So it was all starting to shape up, and it was all proprietary protocols in those days. And I think, I'm sure we'll get on to talk about SCADA stuff and how proprietary protocols pervaded that industry, and how the need for standardization and things that anybody can use, whether they're RFCs for the internet or whether they're standards done through ISO or whatever, are essential for what later become competitors to collaborate to create, and then but to level the playing field and say, right, now we've got this protocol we all agree to speak over, let's go off and do what we do to help our customers do it. And that was the beginning of that. I will mention just one more thing, and that was when we did the Atlanta Olympics in 1996, we did a messaging system which sent live. There was a little Java app that you could have, Java application in fact, you could have on your screen, and you could subscribe to the events and the sports people and the countries you're interested in, and when something happened in the Olympics for one of those sports or people or countries, it would go ding, and lights would come on and it would kind of flicker and all the results would come up for just the things you're interested in. And we implemented that over IRC, Internet Relay Chat, because it was a one-to-many distribution pattern, and we invented a little protocol, a little ASCII based protocol to send over that. And but I kind of looking back, and this was only 2 years before the start of the MQTT work, that was the precursor to one-to-many pub-sub, publish and subscribe messaging. So it was all starting to plant seeds in my mind for what came later.
That's helpful. So Clemens, would you talk a little bit about what you consider to be, the sort of origins of messaging, and talk about your own entry into that space?
Yeah, let me talk about my entry. The parallels are going to be quite stunning, I would say. So 0216657775 was the phone number of my BBS that I ran. in in 1988,
I don't think I ever called that one.
It was called Programmer's Paradise, and it was a FidoNet node. And so and back in the day in Germany, running high-speed modems was punishable by a law with 5 years in prison for interfering with telecommunication systems. So quite serious business.
Wow.
But we ran the US Robotics HST modems anyways, with special setups and ripcords, and so if the postal man came, then we had to go rip this out. Everybody in the family was instructed. So my distributed systems origins also come from speaking with other people, that like email and dealing with all the protocols, kind of doing some low level work there. And then also in parallel, I was, with all the modems, I worked at Funny. The Greeks wanted to have the 1996 Olympic Games, of course, the centennial.
Yeah.
They didn't get this because Coca-Cola is in Atlanta and was a big sponsor. So the Greeks were very, very unhappy that they didn't get the Games in 1990. So in 1991, they set up the Mediterranean Games and said, well, we have everything ready. We're going to go and make a big thing out of this. And I went with a German production company to help with those Mediterranean Games. And my job was to go to the various sites and connect the modems and make sure that the transfer of the sports results could actually happen consistently. So parallels there, Andy. Interesting. So I do a talk in currently that's called "What is a message queue and why would you use one?" And the introduction to that talk is I speak of messengers in general, right? And I have a lady with a carrier pigeon in her hand giving her a love letter. I have couriers who take telegrams, back to the people who should receive them. Mm-hmm. I have couriers with carrier pigeons who were in the field in the First World War, ensuring communication between the soldiers in the trenches on all sides. And I think ultimately what we're doing here in electronics is kind of in a thousands of years of Roman postal service tradition of getting data from A to B, and we're kind of building the modern kind of form of infrastructure of getting that data from A to B, but not in days or weeks, but in milliseconds. And we have the first formal infrastructure that I know of that had the name of a queue on it, and that you could go and run as a piece of software and send something into and get something out of, was an IBM 360. So System 360, built for, in large part, funded by the Apollo program in the United States. And they came up with, in 1964, 65, they came out with that first version of a complete application platform that then also included formally in the telecommunication subsystem a queue system, and I consider that kind of the first really queuing infrastructure that existed.
Cool. I'm glad we were there at the beginning.
Yes, you were. Well, nobody else was there at the beginning, so you were there.
Yes, by default, yeah.
I had no idea the Olympics were going to factor into this conversation. This is so exciting. Well, and also, I'm based in Atlanta, so this is, I feel like I'm at the heart of this. This is, you can either blame me or thank me. It's no accident that, in my efforts to understand messaging, I invited guests from IBM and Microsoft. These companies have been instrumental to advancing message-oriented middleware from the beginning. And as insiders, I'm extremely interested to hear about the sort of internal levers that were pulled behind the scenes. How did you identify messaging as a sort of worthwhile area of investment? What sort of incidents got the ball rolling? Would you want to begin again, Andy?
Yeah, so I think the key thing to focus on is asynchronous messaging. So as Clemens has just said, so queue-based messaging. And obviously people have been wiring computers together and wiring applications together for a long time. But it was always in a synchronous way. So in other words, one application had to be ready to receive the message before it could start sending it. You had to receive the whole message and acknowledge it before either could carry on. And we used to compare that to the wings of we used to say a 747 back in the day, because obviously it shows how long ago this was. The wings of a jumbo jet, when it was going down the runway to take off, the wings actually flap slightly. I can't see them on the camera there. They go up and down slightly, because if they were rigid, they'd snap off. So they have to have that flex in them, and by putting a queue or a springy connection in between two applications, you stop them being rigid and then one of them snapping off when the whole thing breaking. You allow them to a little bit of flex. So this one's not quite finished the previous job yet. Message goes into the queue. This one can carry on with what it was doing. This one will pick it up when it's ready, and it just, that give and take in the system allows the whole thing to carry on without it all having to be in strict synchronous lockstep. And it turns out that was the only real way to proceed with it, the complex situations, applications, people, sensors, all the things that were in an enterprise. So this idea of queue-based messaging came to pass, and IBM had MQ series, which later became WebSphere MQ, which was literally point-to-point queue-based messaging. So you'd put a message into a queue, and at that point application A could consider it actually delivered to application B, because technically it was, because we had this assured once and once only delivery. So once you put it into the queue, that was it. You could safely forget about it. There'd be no retries, there'd be no comeback. It had gone. It would at some point be delivered to application B. And that was a very powerful concept. It means you didn't have to store it in a database locally, get in case there was any retries or anything. Once it had been accepted by the messaging system, and we used two-phase commit to do proper transactions, so you could take it out of a database, put it into a queue, delete from the database, commit to the queue, and it definitely happened. And banks were starting to financial institutions were beginning to rely on this to transfer money, trillions of dollars in some cases, between the bank clearing systems, because once it had been entrusted to MQ, it was definitely going to be there. One of my customers said that it was a European clearing bank, and they said if we stopped all the MQQQs at this point, there'd be $7 trillion in flight at any given time. I went a bit white and thought, don't lose any, guys. So I went back to Hursley, where all the MQ development work was happening, and I said, just been told that people entrusting $7 trillion at a time to our queue, so make sure you don't lose any. So that was the real founding basis of it. And I guess from that, we then saw this additional thing that often application A and application B didn't talk the same language. So it's a bit like giving a French person and a German person a telephone. One could speak French and one could speak German. They could hear each other but not understand each other. So we had this idea of putting a broker in the middle, where message would be delivered from the application A to the broker, where it could be transformed, like a dictionary lookup or some transformation from JSON to XML or whatever, and then sent from the broker to application B. A and B wouldn't know that they weren't both talking the same language, but they'd each receive the message in their appropriate language. And having that centralized broker then became a very powerful way of essentially putting in additional code that would help glue these applications together. And then we thought of the idea of doing one-to-many distribution. This idea of publish and subscribe messaging pattern came into vogue, and so we all started doing pub-sub with a centralized broker, and that was really the fact you could add an additional application B, C, D, E, whereas application A was just publishing one message into the broker. Applications B, C, D, and E could be consuming that data, and A wouldn't know or care how many people were consuming that data, and that hugely increased the flexibility and the fact you didn't have to keep going back and rewriting application A every time you thought of a new subscriber application as your business grew and your supply chains became more complex and so on. So that really was, I think, probably the blueprint for where we find ourselves today with message-based queuing.
All right, and Clemens, let's talk about Microsoft. What is the role of Microsoft in moving this space forward?
So I think the story of messaging at Microsoft starts with IBM, indeed, and with the role of Windows relative to IBM systems. And in the earliest days, before I would say the mid-1990s, Windows was a client, right? It's Windows NT shipped as an operating system kind of 1992, 93. and really became, there was 2 versions before this, and then we had even a Unix, Xenix before this. But really like a serious game in terms of servers only became realized in the mid 1990s and going forward. Initially, just as file and print servers, rivaling Novell NetWare, which was the dominant operating system at the time, but then more and more as application servers. And during those days, all the mission critical systems were all built mostly on IBM mid-range and mainframe systems, and of course their competitors, but IBM being the biggest business system provider overall. The first wave of kind of application services that came out was in 1997 MTS, the Microsoft Transaction Server, which contained several transaction-oriented services, including a queue, the Microsoft Message Queue, and the goal of the Microsoft Message Queue and the systems around it, including SQL Server, etc., was to provide a small server-based alternative to all the IBM capabilities, and that was kind of the start of client server kind of with PC-based architectures, and MSMQ was an important part of this. That went then on through become COM+. Inside of Windows, there were then new services that were called queued components, where you could go and create a component, create a function, and then you could have a function automatically driven by a message showing up on the queue. That's what you do today when you look at serverless architectures with Lambda or with Azure functions, and you hook them up to a queue. It's effectively the same functionality that then existed. 2000 is when they all came out officially with Windows 2000 as a capability. And then as that happened, we were all kind of entangled, Andy's people and my people, in a love-hate relationship around XML web services, with enormously formal meetings that were worse than meetings of 2 opposing law firms occasionally. But what came out of it was the W-star set of specifications, the web services, SOAP, etc. specs. And they kind of drove a, however successful they were and they are, a lot of that XML stuff is still being used. And a lot of the SOAP stuff is still being used.
For better or for worse.
Yes, for better or for worse, that's right. But it has some echoes that I'm going to get to in a moment. And then what then happened is that out of the team that owned web services in Microsoft, there was an incubation started by John Shushak, which then consisted of 2 people who then explored simply. Now when we are equipping all of these companies with the ability to go and run web services, how do they talk to each other? And reminder, this was before the day of public cloud, before the idea that there would be neutral spaces you could go and run anything under, but there was the assumption that everybody would live kind of behind their own firewalls, and kind of how would that even work? We're now building interoperability, but if they can't talk to each other, how does that work? And they then pioneered the idea of the relay, which is a web service bridge service that lives somewhere in neutral place. Still exists as a service actually in Azure. It's the oldest service that exists, and that was the first beta. The first beta came out in May 31st, 2006. And what we today have in Azure as the fleet of Azure messaging services, which process over 11 trillion transactions per day, is the straight development kind of from that nucleus of kind of building this bridge in the cloud that then actually became part of the cloud services. And since then we've added a queue broker that is speaking AMQP. We also have been driving this AMQP standard with industry partners. That is providing queue-based messaging and is one of probably the largest JMS2 compliant broker in the world, certainly in terms of absolute scale that it runs. We have Event Hubs, which is a Kafka-compatible but also AMQP compatible event stream broker, and several other services, including Event Grid that also speaks MQTT 3.1.1 and 5.0. And Andy can probably talk about me and MQTT at some point. And so we're working in the Azure cloud mostly to build this kinds of services that customers want, and that's how we come up with this large bouquet of services, because it's always, as Andy says, always about getting data from A to B, but there's so many facets, especially on the consumption side, that we keep coming up with new services, and customers keep using that entire spectrum of capabilities. But that's kind of how a short story of how we got there.
Sorry, I was about to say, it's quite interesting how some of those standards have really stood the test of time, although more in concept rather than in reality, in actuality. I was talking to some people the other day who were trying to invent a service discovery system for the internet, and I said, "Oh, don't do that. I mean, it's all been done. I know it was all in XML and SOAP and horrible stuff like that, but go and look at UDDI.
Yes.
Please don't reinvent that wheel, because people died trying to get that thing to work." So, but absolutely, yeah. The other thing that's probably worth mentioning is that you mentioned Kafka, as things kind of have come up to date, and the web era, if we can still call it that, is still well underway. People observe that when this is to do with transactions, when you buy something on Amazon, you click to purchase, and there isn't a two-phase commit then between. We always say you can't do two-phase commit to the eyeball. It's a visual feedback. So send and acknowledge, which I would refer to as QoS1 in MQTT speak, simple acknowledgement, is what we use for buying things on the internet. So surely it's good enough for enterprise messaging. Who needs transactions? So what the youngsters who implemented web interfaces did was they said, "Oh, we don't need transactions, don't all that MQ stuff. It's really, really heavyweight. We'll just do a simple acknowledgement, and then if it doesn't work, we'll retry it, or we'll hold on to the data until we're sure it's there." So they've invented all this stuff at both ends, which is what MQ and other transactional queue-based messaging services, which do exist, implement. Somewhat seem to have kind of fallen from grace in the front end of things, so between web clients and servers. Obviously it's still enormously important for enterprise and B2B, but the kind of the B2C applications tend not to be using transactional stuff. So that's just kind of ushered in this whole new era of lighter weight, less reliable messaging protocols, where either the human has to intervene to confirm that it got there, or you have to retry after a while, or make sure that you don't have idempotency. So if the same message gets transmitted twice, you go, "Oh, we've already seen that one," and throw away the second one. Stuff like that, which you didn't have to do when we just had once, and once only short delivery, bump, it's gone, done.
we fight that fight every day, and so since we have two indigenous services that kind of implement those patterns, Event Hubs and Service Bus, we're confronted with this where customers always come and say, "I want to use Event Hubs for everything." We're like, no, don't do that. So all of the 500 largest Microsoft customers use the messaging services that we have, and all of them, because they actually get advice, all of them use all of the message services that we have, and they do so because AQ has one important feature, and that's not the order or the buffering. It is exclusive assignment. What it does is it gives a processor a job for the processor to own, and then to do the work on. And Kafka and all the event stream processing platforms cannot do this because they don't have any individual tracking of the life cycle of a message. And people build completely absurd contraptions around Kafka to kind of sort of get this.
Exactly, to recreate that functionality.
And the easiest way to get it is to just use a queue. And there's nothing wrong with using multiple of these messaging infrastructures in your architecture, right? If you can stand up a web server in a Kafka, well, then you can also stand up a web server in a Kafka and a broker. So, and then use the right communication path for the right thing. So we're doing that. I'm dealing with this every day. And I'm actually dealing with this internally. I just had an email from an internal team that says, well, we have decided to standardize on everything on Event Hubs. Where is an article that I can read that tells me how to solve this particular problem? Exclusive assignment. And I wrote, if we had an article about this, it would say, don't do this. So, so I said, don't. And I said, this is an authoritative answer. Do not do this, please. And so yes, Andy, I feel you. There is a lot of propaganda that's around from the younger companies. And I call this one pony architecture, because if you only have one pony to sell, then you're going to try to do everything with that one pony. But that pony doesn't know all the tricks. So, use something where you have appropriate infrastructure, appropriate patterns, basically, for the problem you're trying to solve.
Glad we brought in Kafka at this stage, because it is certainly the flashiest paradigm in messaging, especially at the edge, that we talk about here at RedMonk. And I actually spoke with Alexis Retcherson, the founder and CEO of Rabbit Technologies here at VMware. But he talked about the fact that there is a lot of contention about whether streaming is a separate use case. And today it's becoming sort of table stakes with RabbitMQ and NAT supporting streaming. So I guess I'm certainly interested in hearing more about your sort of sentiments about streaming as this paradigm. But would you agree with that characterization, that it is sort of becoming table stakes? It's just everyone is supporting this now?
Yeah, why all the platforms are somewhat alike, if you look at AWS and Google and Microsoft and also what IBM's offering, is that every year we go through the dance with analysts, where we get a questionnaire with 500 different questions, and that's not an exaggeration. And they basically kind of nudge you into what the table stakes ought to be and what you ought to support, and you don't want to come up blank in any of these categories. So it ends up being that the consensus amongst analysts kind of drives lots of the feature work, really, which is kind of funny, because the customers should drive it, but there's lots of checkbox, make the analysts happy work that is happening. So meanwhile. Go ahead.
Then it becomes a self-fulfilling prophecy. Exactly. Yeah.
Yes, they do. And so yes, streaming is table stakes, and building better and better streaming platforms is a huge area of in the competition between us and AWS and the likes of Confluent, etc., to make streaming better. But it is a different category from transactional job processing. It is about, if you look at if you look at how Microsoft presents itself right now in the marketplace around streaming, you hear a lot about Microsoft Fabric. Microsoft Fabric being our big data platform, which has all the various data engines integrated, and Spark and all these things kind of in one box, that is speaking to the analysts, the data analysts, and some of the data engineers more than to application developers, because that's where lots of the usage of streaming is. And jobs processing, queue-based processing is more on the application side. So it's split itself into kind of a data story, like, of course, usage in application, but very much a data story around streaming, and an application integration story around queuing. So I think these are things that everybody needs to have in their toolbox to build apps. But we'll see more and more kind of data-focused, data-centric development around streaming specifically.
Although I think it's fair to say that one person's streaming is another person's discrete messaging. And obviously a stream is just a series of discrete messaging. And if you look at the notion of a session across a number of messages and reduce the overhead of each message, the header, then you've effectively turned a series of discrete messages into a stream. So it's a very grey line between, is that a stream or is that a continuous stream of discrete messages? So it's always a boundary that you can step either side of depending on what you want to achieve.
I want to return to something that we had talked about before, which is the idea of sort of open source and open protocols in messaging, because I think that's a really important part of this story. And you sort of mentioned the going into rooms and arguing about specifications. I feel like this is all part of that. So, the complexity of the space seems to call for this. So talk to me about the history of open protocols. Like, what does that look like? What do you think are some of the more important parts of that story?
Well, I'm going to talk about MQTT.
Please.
I've got the T-shirt.
Yes.
And MQTT is 25 years old on the 22nd of October.
Yes.
It's essentially so this was invented as a SCADA protocol for remote telemetry for oil and gas pipeline systems. And back then there were, going back to our conversation about dial-up modems, there was no real packet switching, no real internet being used on these links. So a central computer would dial up a remote sensor and say, what's your reading? And then it would go on to the next one. The next one's called pole response. And there were hundreds and hundreds of proprietary protocols that were being taught across those dedicated links. Almost from the same manufacturer, you'd get variants of Modbus and Allen Bradley and Honeywell and all these different protocols, literally hundreds of them. And it was becoming impossible to support all of those at the enterprise end. When all those messages were coming back, you'd have to decode each one from each different protocol, and every time you bought a new sensor or replaced one or upgraded it, you have to implement another protocol across all your applications. It was becoming seriously unworkable. So we said, this was me and Arlen Nipper, who was working then as in the SCADA industry, supplying the little boxes that go out at the far end of these links, and we said, what if there was just one more protocol? It was very simple to implement, very easy to understand, very small footprint on the device, because those devices were only sort of really small and crummy, sort of Z80, 16K memory type things in those days. Not very chatty on the wire, because connections were either slow modems or really expensive satellite links. And imagine it wasn't proprietary and you didn't have to pay for the spec, and it wasn't 300 pages long. It was really small, simple protocol, and it was public domain, open source. Didn't really use the term open source in those days. It was put it into the public domain from day one. So anyone, there's just one more protocol you've got to implement, and that's the kind of the one ring to bind them all. And that's what became MQTT, which has been open and free since its inception. The protocol was standardized as a OASIS standard and an ISO IEC standard. And the people who collaborated to create those standards then competed by implementing it the best. The server end, more scalable, more robust, more sort of cap semantics, consistency, availability, and performance. I always forget what the C stands for. Those three things can be traded off. So people made their livings. There are many companies that have sprung up because of MQTT. I was talking last week to HiveMQ. They've developed a broker, and they run a very successful business just because of MQTT, which I'm very proud to know. And that really, when everyone's talking the same protocol, the things you can then implement, it gives good reason for device manufacturers to burn it into their silicon. It gives application vendors good reason to support MQTT in their applications, because it's always the same, whether it's 3.1, 3.11 or version 5. It, in a sense, doesn't matter as long as it's the standard. Then you can guarantee to interoperate, and that's the wonderful thing about standards.
All right, and let's pause on this before we move on to AMQP, which I'm hoping we can also dig into. So with MQTT, talk to me about where this space is going, because 25 years is not a small amount of time in terms of computing. Do you think that it still retains the robustness because there is continues to be this need in the IoT space for a service like that? And when it comes to open source and open protocols, having agreement in the community that this is the way we're going to go can sometimes have give and take. I mean, I talked to a lot of folks who are excited about Rust right now, but a lot of older services aren't written on Rust, and so maybe they're a little bit slower, but they are going to be interoperable, right? They're going to work for everybody. So so how do you perceive the future of MQTT, and why are you still excited about it? A quarter of a century later.
Yeah, well, as we were saying on a podcast just a few days ago, I mean, we're raising a glass to the next 25 years of MQTT, because its popularity shows no sign of slowing down. In fact, in many ways, it's the nature of an exponential curve. It took 10 years for anything to happen, pretty much. I could have enumerated all the projects in the world that were using MQTT, because I was hands-on involved in all of them. But then after this kind of tipping point around 10 years in, a lot of what was fueled by Roger Light creating Mosquito, which is the open source MQTT broker, and other things as well. This exponential curve took off, and now we're not just seeing it in the IoT world. We're seeing it in many application areas. We're seeing people using it for I heard there's an antivirus company that's using it for talking to all its endpoints, updating all the antivirus things. Some major car manufacturers are rolling out millions and millions of cars which use always-on MQTT connections for their calling back home. We're seeing it all over the place, and it's becoming not a replacement for enterprise messaging, because obviously there are lots of features, transactionality being a key one, heavy duty, as I might call it, enterprise messaging that needs a fiber or LAN to talk over, makes perfect sense for. But for anything else, the low bandwidth end of things, or where you've just got to link two applications together, and you don't want a lot of this standardization is that you don't need to care about what's below you. The reason we use TCP/IP is that you don't care what's down in the gubbins of that. With MQTT, you don't need to worry about how it does it or how it works. You just decide what will you send and what will you do with it when it gets there. And being freed up from having to worry about anything else is so liberating, because you spend all your time then worrying on the application domain, helping your customers with what they're worried about. And that's what makes it, because it's so easy to use, so easy to download a client, so easy to get working. I was talking to a colleague last week, and he said, "Oh, we used MQTT for this project." I said, "Great. How did you find it?" "Oh, we just downloaded the library and started using it." And no, that was it. "Oh, okay." Boom, done. There was no further discussion needed. Great. That's what it's for. That's what we hoped when we invented it. People would find it easy to use.
Oh, all right. The next 25 years then. Well, Clemens, would you mind talking a little bit about your sense around open source and open protocols? And I know that Microsoft uses MQP for their messaging service, so maybe that would be a good place to start. But I also understand you have some experience with MQTT, so maybe you want to talk about that.
Yeah, let me connect to the MQTT piece first, and then I'll talk about AMQP. We had looked at MQTT, started to look at MQTT when this IoT, at the beginning of the IoT wave, when IoT became a term, and we were already building cloud services at the time. So now I'm talking 2012, 2013, just about that time. And then, and the MQTT standardization was already going on. So IBM had donated their 3.0 version kind of into Oasis for standardization. And the charter was such that it was mostly like edit what we have and then turn it into a standard.
Yep.
And the charter of the working group basically said, we can't make any incompatible changes on this. Okay, so we did an analysis on this, or I did that analysis on it, and we found that for implementing this in the cloud service, it would be difficult in some places because of error handling issues and a bunch of other things. We made a list. Then the IBM folks were done with that work. I made a list public, and then we ended up having a formal discussion internally between IBM and Microsoft, and said, hey, we'd like to participate in the next round of this. And then we ended up having a few folks involved in the next round, which then turned out MQTT 5, which is a super robust protocol with proper error handling, extensibility, etc., which is I think a lot better than 3.1.1, and it's everything around MQTT is open industry collaboration. It's a fantastic protocol specifically for connecting out to the edge, and we're using that for automotive fleets. We're also helping the OPC Foundation. That's another big story around standardization. OPC Foundation Industrial Manufacturing, who are adapting their PubSub standard kind of to MQTT, or running that over MQTT. There's also other things where we are Sparkplug B is a standard in industry. It kind of sits on top of MQTT. There's a lot of good stuff going on even in the verticals. So AMQP, since we're a history podcast, AMQP was a reaction of Wall Street or the banking industry to IBM's dominance in the space, and to TIBCO's dominance in the space. And so IBM was not supportive or happy about AMQP when that all started. And I have for quite a while I thought that it was truly evil, malicious intent, as you are if you're a young person. But what I found later is, and through speaking to people, is that a lot of IBM's hesitance to document their protocol properly, because that's ultimately what was one of the complaints was of JP Morgan, who's kind of started this, but also the other banks that worked on it, is that they didn't have any documentation for the IBM MQ protocols, and so therefore could not build services that were not depending on IBM. But a lot of the IBM protocol was really just, there was code on one side and there was code on the other side, and it kind of made it happen. But there wasn't any formal like protocol spec that says, like an RFC, that says this is what the IBM MQ protocol was. It was basically, and there was 3 versions, I think, of that code, where there were 3 protocols that were the IBM MQ protocols effectively, but there were effectively just the implementations of what happened on either side. So in terms of technical debt and whatever we talk about, right, you can almost understand that, that's how it happened. So ultimately what was needed was an open, spec first protocol that everybody can then go and implement. And JP Morgan started this, and then they got a bunch of people to consult on this. Amongst them, I should and want mention my friend Peter Hitjens, who unfortunately passed away and left us. And he was a staunch opponent of big corporate entities, I would say, including IBM and Microsoft. And certainly we didn't see eye to eye in the beginning, but then towards his unfortunate passing, we really became friends, and I got to see him. So big props to Peter Hitjens for doing lots of that work. So AMQP ended up being standardized, not without hiccups. There was a 0.9 version that defined very clearly inside of the protocol the role of a queue and the role of an exchange and the role of subscription, which was very rigid as a built-in topology. We were against that. Other banking customers were also against that. The Rabbit people were for it, and so there was the AMQP schism that then happened, where the RabbitMQ people stayed on 0.9 and evolved that a little bit, but on their own. And then the rest then moved on to AMQP 1.0. Apache Artemis and the Apache Cupid projects, they are kind of open protocol AMQP brokers. We implemented AMQP in our broker. The Solidus folks implemented AMQP. There's an AMQP bridge that sits in IBM MQ. So there's numerous brokers that implement AMQP kind of as their primary protocol, and I'm super, super, super happy that the RabbitMQ folks finally came around. They just shipped last month the 4.0 version of RabbitMQ, and that now has AMQP 1.0 as the primary protocol. And if you read what they're saying in their blog release, they're also saying, yeah, 0.9, we've been sitting on this for a long time. Here's the kind of backstory, but sorry, and now we're going to go and do this interoperably. And they're actually using the stacks that we built for .NET as going forward as their client, as do the Red Hat folks who are kind of maintaining most of the Apache brokers. One of the great stories, I think, around open source in that context and harmonization is the second phase of AMQP standardization happened like four years ago, maybe, where we sat down mostly with the Red Hat people to work on a set of companion specs with the goal of creating one GMS provider that would work across most AMQP brokers. So we wrote a bunch of standard specifications to enable this, connection management, etc. And then we worked together on the Apache Cupid JMS project to build this one client that supports everything, all the features of JMS2, including transactions, on top of that common base. And so we're now at the place where Azure Service Bus, Apache ActiveMQ, Artemis, and Apache Cupid, these 3 brokers share literally the same code, the same client provider for JMS, which is fantastic from an interoperability perspective, because JMS is terrifyingly bad in terms of an API feature set, because it has a lot of weird things in the corners. Like the overall model is kind of okay, but once you kind of go and niche around the corners, then it's awful. But so we did all of that work once, and not everybody had to do it again. And so that's a great achievement. And of course, it sets us up, including now RabbitMQ implementing AMQP 1.0 completely, that we now get to a place where this entire enterprise messaging space can basically move on, and we can go and create a single set of clients for each language, and then just compete on quality and scale, rather than competing on API this and that and this and that, because we all are now in the place where we have interoperability. So big story. And if I may then add another standard, another thing we did, and that's something we did in the CNCF with 40 companies, including IBM, but many more, is CloudEvents. And CloudEvents as a way to standardize what an event is, independent of what protocol it travels over. Because what we see more and more is that an event is being emitted from a device over MQTT. It just lands in the cloud and then is being forwarded into a Kafka broker. It then is being picked up and is being forwarded into a queue for transactional processing. So it kind of makes all these hops. Of course, if you are protocol dependent, that's a problem because you're kind of losing information. And if you don't have a well understood way of mapping these events, then this implementation is going to be this implementation is going to be this. And so what we did is build a metadata model. And tying back to what we said initially, what Andy said is like, these web services standards have some good effects. We have been referencing SOAP many times in those discussions about CloudEvents as an example for things that we should not do. and amongst them was we didn't want to invent a new protocol. Right? We didn't want to go and abstract the protocols about what we said. We're going to be citizens in your house. Right? You're going to do Kafka. We're going to do Kafka. We're simply going to go and map our properties onto whatever the Kafka properties are. And you want to use XML? Go use XML. You want to use JSON? You're going to use JSON. We're going to map our models onto whatever the encodings are that you have. And that's making CloudEvents more and more popular. So it's trying to foster interoperability by simply creating a convention. And one of the instrumental people there has been Doug Davis, who started at IBM, then was with Microsoft as the chair of that group. And we've been doing, and with lots and lots of contributors, we've been doing great work. And a follow-on to this is the work that we're currently doing in X Registry around metadata, a holistic metadata model about messaging and kind of formatting streams, etc. So we do, as a principle, all of the wire protocols that we do in the Microsoft messaging services are all based on open standards. And what I'm super happy about is that in the messaging space, we have been really disciplined, I have to say, around how many protocols there are. Because we could be having 20 standards, but we really only have like 5 that are complementing each other pretty well. So we have MQTT is the choice for attaching devices and low bandwidth devices, and for kind of this open namespace PubSub model. We have AMQP as the number one choice for transactional messaging, and then we have Kafka has become kind of a go-to, I mean, not a formal standard, but has become the go-to API, where we now have lots of competing implementations on top of the same API standard that also kind of creates a level of inertia in the Kafka project, for better or worse, that is now effectively becoming something that you can go and lean on also with many competing app implementations that use that as the standard. And AMQP can also do that streaming work. So we're in a good place, I think, in terms of open standards and open source.
And we should probably just mention XKCD 927 as well, which is the one that we enough standards. One of them doesn't quite do what you want, and just create a new standard.
Yes, and I think we're pretty good about we're pretty good about not having that. There are a few newcomers, which are, but they're doing kind of like NATS, for instance, right? NATS is text-only protocol that is complementing all of that bigger set nicely, because it's very low. It's very, very simple, right? If you need the simple thing, you can use NATS. But they're all very nicely differentiated, and there's very little true overlap in the use cases. And I am very happy that we and possibly also, with some help from maybe from us, that we're not looking at a space that is as fractured as maybe in other places like the database space.
Absolutely. Yeah.
All right. Well, I've only touched on about a third of the questions that I'd hope we'd get to, and that doesn't surprise me in the least. But we are about out of time. So before we go,
together in a room.
I know. Yeah, this is a to be continued conversation for sure. Before we wrap up, though, are there any ways that folks can follow you on social media? Where do you typically post your musings? Do you have a blog? How can folks keep up with you both?
I used to be on Twitter as AndySC, but now I'm not because of what Elon does, and I'm on Mastodon instead as AndySC.
Yeah. I'm Clemens V on various forums. You can probably most technical content I post on LinkedIn these days because yes, the old place that Andy left, I have not left yet, but I'm still I'm about to maybe. Because it's untenable, so I moved most of that technical content to LinkedIn. I'm always hoping that I can blog again or will blog again. It will be disciplined enough to do it. But if I do, then I will also link my posts there, and you can go and find me very easily on LinkedIn because my name is not ambiguous. So find me Clemens Vasters or Clemens V on most platforms.
Fantastic. I've really enjoyed speaking with you. And again, my name is Kate Holterhoff, Senior Analyst at RedMonk. If you enjoyed this conversation, please like, subscribe, and review the Monkcast on your podcast platform of choice. If you are watching us on YouTube, please like, subscribe, and engage with us in the comments.